What if a magnetar entered our solar system? Imagine a day in the distant future when the fabric of the night sky subtly changes. At first, astronomers are the only ones to notice. Their telescopes reveal a tiny anomaly, perhaps a strange spike of X-rays, maybe a whisper of radiostatic from deep space, far beyond Neptune's orbit. It's intriguing, but not alarming. Little do they realize that this signal marks the entrance of one of the universe's most exotic and dangerous objects into our own cosmic neighborhood, a magnetar. A magnetar is a type of neutron star, born from the death throes of a supermassive star. When such a star ends its life in a catastrophic supernova explosion, its core collapses, crushing protons and electrons so tightly together that only neutrons remain. The result is a tiny, extraordinarily dense sphere, no larger than a city, yet containing up to twice the mass of our Sun. And if, in those moments, the nascent neutron star acquires an exceptionally strong magnetic field, some 1,000 times stronger than ordinary neutron stars, it earns the title of magnetar. The true terror of a magnetar, though, is not its weight or size, but the unfathomable force of its magnetic field. Magnetars boast the most powerful magnetic fields known to science, up to 10-15 Gauss, or about a quadrillion times stronger than Earth's own magnetic field. For perspective, bring a fridge magnet close to a compass and watch the needle shiver. Now imagine a force so colossal that at a distance of 1,000 kilometers, it can erase the data from every credit card on Earth. Up close, it can rip atoms apart, distorting the fabric of matter itself. The arrival of such a cosmic dynamo in our solar system would be a catastrophe unlike any other. In the deep freeze of the outer solar system, perhaps somewhere beyond Pluto, the approaching magnetar glides along on its inexorable path. Still thousands of astronomical units from Earth, it's already a source of fixed fascination for the astronomical community. Telescopes are turned to track it. Space agencies hold meetings and briefings, quietly trying to assess the risks. At first, as the magnetar drifts closer, signs are subtle but unsettling. The solar system's most tenuous elements, plasma in the solar wind, faint gas clouds lingering at the system's edge, begin to twist and churn in response to the alien magnetic presence. Auroras not only on Earth, but on Jupiter, Saturn, and even distant Neptune, start to glow with anomalous brilliance, pulsating in unfamiliar hues. Space probes in the far reaches send back weird, garbled signals, or simply fail entirely. Only, their electronics fried by invisible, fierce surges of magnetism. For the first time, the event becomes front-page news worldwide. People gaze up at the night sky, wondering where in that vast darkness this strange star is lurking. Some hope to glimpse it with binoculars or telescopes, but at such distances, a magnetar is merely a dot, bleak, cold, and invisible in optical light, betrayed only by its X-ray and gamma-ray emissions. And yet, day by day, the effects grow stronger. The Sun, a living star with a magnetic personality of its own, reacts warily. Solar flares become more frequent, more intense, a possible consequence of magnetic interactions with the invading body. Solar wind, the constant stream of charged particles flowing out from the Sun, becomes turbulent, writhing in unseen wrestling matches with the magnetar's field. The most immediate victims of this cosmic visitor are the outer planets. As the magnetar enters the Kuiper belt, its titanic field sweeps aside dust and icy debris, sculpting voids, twisting objects from their slow, silent orbits. The intricate dance of Pluto and Charon is disturbed. Kuiper belt objects are jerked onto new trajectories. Some are slingshotted into interstellar space, while others are sent plunging sunward on erratic, perilous paths. But the true havoc begins when the magnetar draws closer, within a few hundred astronomical units of the Sun, deep inside the solar system's Oort cloud. Here, it encounters a vast reservoir of icy bodies, the source of most comets. The magnetar's gravity, though intense, is not the main issue. It's the magnetic fury that counts. The Oort cloud is shredded. Cometary nuclei are knocked loose, hurled toward the inner solar system in apocalyptic cascades. The night sky, once serene, becomes a battlefield of falling stars. Showers of comets streak across the heavens, endless and terrible. Back on Earth, the consequences become ever more dire. The Magnetar's X-ray and gamma-ray emissions now outshine all but the Sun itself in certain wavelengths. Protective layers of planetary atmospheres are tested as high-energy radiation slams into them, generating secondary showers of subatomic particles. Satellites in Earth orbit blink out, their circuits overloaded or destroyed. Communications fail. The global positioning system, critical for navigation, communication, even banking, collapses. The planet's magnetosphere, normally shielding us from cosmic dangers, is overwhelmed as well. Earth's auroras, once a delight of the polar skies, now rage across all latitudes, blood red and green flashes. Electric in the night, miirisit. Over New York, Beijing, Mumbai, Cape Town, Sydney. Power grids, designed to handle the mild geomagnetic storms of the solar wind, are pummeled by geomagnetic pulses 1,000 times stronger. Transformers fuse and melt. Blackouts become widespread, persistent, and ultimately permanent. On the biological front, high-energy radiation doses soar. The Magnetar's onslaught shatters ozone molecules, punching holes in the stratosphere. Ultraviolet rays from the sun, no longer blocked, wreak havoc on unprotected skin and eyes. Crop failures sweep the globe as growing seasons are ravaged by a combination of unreliable sunlight, climatic upheavals, and relentless radiation. All the while, humanity's scientific elite scramble to understand, to measure and predict, to warn. Yet, the facts are stark. There is no technology capable of shielding a planet from a force such as this. Survival depends on luck, ingenuity, and the hope that the Magnetar will simply pass by, close enough to terrify but not destroy. But what happens if the object comes even closer? Suppose, by bizarre cosmic coincidence, the Magnetar's trajectory brings it toward the very heart of our system, the Sun's immediate neighborhood, maybe even the orbital paths of the planets themselves. Now the true nightmare unfolds. At close range, the Magnetar's gravitational pull distorts planetary orbits. Planets are tugged from their places in the clockwork harmony forged over billions of years. Mercury might be pitched into the Sun. Mars could be ejected into deep space. The asteroid belt is ripped apart, sending mountains of debris earthward. For Earth, the torment is unprecedented. Not only is our planet battered by extreme radiation, the magnetic field of the Magnetar warps and bends the very atomic structure of matter. As it approaches within a few million kilometers, iron atoms are stretched like spaghetti. Chemical bonds dissolve. Compasses wildly misalign. Electronic devices anywhere near the surface spark, melt, or even explode as electromagnetic forces tear through circuits. In these final moments, life's delicate infrastructure is destroyed. Air and water molecules are split apart into their constituent elements. Cells, the basic building blocks of all known life, lose their structural coherence. Proteins unravel, DNA shatters. Life, as we know it, cannot survive in such conditions. Even the planet itself is threatened. If the Magnetar's gravity is strong enough, it could unbind the Earth from the Sun, putting us on a slow, cold death march into the abyss of interstellar space. Alternatively, tidal forces might rip the planet apart, reducing it to rubble as the Magnetar passes by. And yet, even if by some astronomical chance the Magnetar passes at a safe distance, never coming closer than Pluto's orbit, the long-term consequences for our solar system remain profound. Comet storms could continue for centuries, as the inner solar system is periodically swept by the debris the Magnetar's passing kicked loose. Outer planets might be wizened husks, their atmospheres stripped, or compositions altered. The delicate balance that allowed life to thrive on Earth would be upset, perhaps forever. But the most haunting effect might be the permanent change to our sky. Magnetars, even after passing by, can leave lingering signatures, charged particles that shimmer, ripple, and fade in the cosmic background for millennia. The Sun, reeling from its interstellar visitor, might flare and flicker, its cycles altered. And at the edge of the void, the former intruder will have left its scars, on comets, on planets, on our hopes and histories, all because a city-sized star, dead for millions of years, wandered just a little too close to us. To fully appreciate the scale of this danger, consider what a magnetar truly is. Neutron stars themselves are among the densest objects known. A teaspoon of neutron star matter weighs around 1 billion tons. But with magnetars, this density is paired with a lethally powerful magnetic field, forged in the supernova that spawned the star and then rapidly wound up and intensified by the star's own rapid rotation. These objects are excruciatingly rare. Out of the billions upon billions of stars in the Milky Way, only about 30 magnetars are known to exist. Their ferocious magnetism makes them relatively short-lived. Strong fields decay within about 10,000 years, after which a magnetar becomes more like a normal, if still terrifying, neutron star. Astronomers study magnetars from afar, grateful for every light year that separates us from these celestial monsters. Magnetar outbursts are some of the most powerful phenomena observable. A single flare from a magnetar, thousands of light-years distant, has been known to disrupt satellites and telecommunications at Earth. So what causes these gigantic bursts? Pressure and stress build in the rigid iron crust of the star, strained to breaking by intense magnetic forces. When the crust yields, the result is a starquake, a violent rearrangement of matter on a subatomic level. The energy released is beyond comprehension. A massive flare in 2004 from the magnetar, SGR 1806-20, released more energy in a fraction of a second than the sun emits in 100,000 years. Now, imagine this not from the safe distance of tens of thousands of light-years, but from close at hand. Even outside the solar system, a magnetar's flare could damage our technology. Within the system, in the Oort cloud, the Kuiper belt, even the outer planets, the devastation would be total. Flares would overwhelm any unprotected electronics. Humans in space, even within thick radiation shielding, would not survive. Even at a safe distance, the magnetic influence of a magnetar reshapes orbits and planetary environments. Take, for example, Jupiter, the solar system's magnetic giant. Jupiter's field is a bare fraction compared to a magnetar's. The sudden intrusion of this colossal magnetic field could destabilize the planetary magnetospheres, bombard atmospheres with energetic radiation, and drive fantastic auroras and storms across their surfaces. The enormous gas giants could see their moons stripped, atmospheres burned away. These possibilities aren't mere science fiction. They represent legitimate threats mapped out in equations and simulations. That none have ever come to pass is a testament to the vast loneliness of interstellar space and the rarity of magnetars themselves. But suppose, in some nightmare scenario, that a magnetar were to somehow teleport within the orbit of Mars. Gravity would cease to be the main concern. The magnetic and radiative onslaught would be so intense that even matter itself would be rewritten. The electrons and protons that make up atoms would be whisked from their orbits, creating a dense, featureless plasma. Biological life would not only stop functioning, it would dissolve, reduced to its elemental parts at the most fundamental level. Yet, perhaps even more terrifying than the abrupt end, is a slow disaster, a near miss that leaves the solar system permanently changed. The orbits of planets would be skewed, with the careful resonances and stabilizing patterns disturbed. Over thousands or millions of years, these changes could lead to new collisions, ejections, or even the destruction of the very order that sustained Earth's climate and habitability. Life might hang on for a while, but in a world increasingly unpredictable and inhospitable, contemplating such an event reminds us of the extraordinary fragility of our home. For 4.5 billion years, the solar system has drifted in a relatively quiet region of the galaxy, rarely troubled by passing stars. Our sun holds dominion, its gravity balancing the planets, its heat and light nurturing all living things. But the Milky Way is not static. The galaxy rotates, stars wander. Extraordinary objects, born in distant cataclysms, can appear at any time. What if, by sheer misfortune, a magnetar, distant across the void, fated to pass through our cosmic front yard, became our next neighbor, humanity would face a challenge on a scale never experienced before, perhaps never even imagined. There is currently no technology, no spacecraft, no shield that could ward off a Magnetar. Survival might depend on flight, colonies flung to distant worlds, underground cities battened against storm and flame, desperate measures to save fragments of civilization and memory. Or perhaps our fate would be sealed with the first wave of radiation, the wiping of our technology, the unraveling of our biology under a magnetic field that erases the very definitions of chemistry and life. It is a chilling possibility, but also a reminder. The universe, in all its beauty, harbors dangers beyond human scale. The stars we see at night are distant, yet their lives and deaths shape our destiny. Magnetars are among the universe's most awesome and most deadly creations. That we can observe and study them from afar is good fortune. But if one ever entered the solar system, all we could do is bear silent witness to the ultimate power of nature, a force so mighty it can bend atoms, crack planets, and end worlds. Thanks for sticking with us until the end of the video. What do you think would really happen if this became reality? How would the world change? Share your thoughts or your own what-if theories in the comments below. Who knows, your idea might inspire our next video. If you found this interesting, don't forget to like, share, and subscribe to keep exploring the wildest possibilities with us. See you in the next unexpected what-if adventure.